In this segment, we're going to compare Earth and Earth's moon. When we look at the surface of Earth, we see that 70% of the surface of Earth is covered in water. And that leaves only 30% for land. Now, underneath the land and underneath the water is called the crust. Earth's interior is broken into 3 big layers. You've got the crust, which is the outermost layer. You've got the mantle, the next layer in. And then you've got your core. When you compare and contrast, the crust is really thin. The crust is a very thin layer over the thicker mantle and the even larger core. Now, the crust on the Earth is thickest underneath the continents, the land, and is thinnest underneath the oceans. Now, the crust is very thin, and it can break when it is stressed. The mantle, on the other hand, is more of like a plastic, meaning that it's very pliable or very bendable. The composition of the mantle is dense rock. Now let's look at the core. The core is broken into a liquid core and an inner metallic core, much more dense core, a solid type core. Now when we refer to metallic, on the Earth we mean iron and nickel. So the metallic core, whether it's liquid or whether it's solid, is made of iron and nickel. Now, as shown, the interior of the Earth has differentiated. It has split into layers, and the layers are defined by density. So the highest density is in the inner core, and the least dense layer is going to be the crust. So the highest density materials sink to the center of the Earth, whereas the lightest materials float to the top. So the crust is the least dense, and the more solid core at the center is the most dense. Now let's compare Earth's interior with that of the moon. Now when we look at the interior of the moon, we see 2 distinct layers. We see this grayish layer, and then we see this orangish layer in the center. Notice you see dashed lines around this core region. We're not really sure if there is a core inside the moon, or its size, or its composition. Hence you see these dashed lines there, because we aren't really sure. The rest of the moon is this mantle, and it's mainly a composition like Earth's crust. So even though the Earth has a mantle, that composition is more of a plastic pliable, whereas the mantle of the moon is more like the crust of the Earth. That is, it's more brittle. Now the moon has a very low density, and that indicates that it doesn't contain much iron. So we're not going to find some kind of liquid metallic core or some kind of solid metallic core in the center of the moon. When you look at the surface of the moon, you see it's divided into 2 dramatically different kinds of terrain. The dark gray areas that you can see from Earth by the naked eye on the surface of the moon are the smooth lowlands, which are called mare. These are dried basalt seas, and so they would be somewhat akin to the oceans or the seas that you might see on the Earth. But these mare would be like lava seas of dried basalt. In contrast to the dark regions, you see these very bright regions. These very bright regions are heavily cratered highlands. Now on Earth, we don't have these heavily cratered highlands because we have erosion on Earth. There's very little erosion occurring on the moon, hence we can still see these heavily cratered highlands. Now, how is it that the moon has rocks that are very similar to the crust on Earth? Well, there came an idea of how the moon formed, and it's called the Large Impact Hypothesis. This hypothesis proposes that the moon formed when a very large planetesimal about the size of Mars had struck the proto-Earth, the very, very young Earth. Such a collision would have ejected debris from the crust and the mantle into space. And model calculations indicate that some of the debris would then have settled into a disk in an orbit around the proto-Earth. And then eventually that material would have quickly collected to form the moon. This could explain why some of the composition of the moon's rocks are very much similar to Earth's crust.